Adjunct Professor Moran, Macroeconomics 111. We're going to do in this session the complete aggregate expense Keynesian model. Should be an E there. A single aggregate expense line. So all this represents one single aggregate expense line. We were discussing in prior sessions the private closed model, where there was only consumption and business spending. And what that did for us, there's only one leakage, and that leakage is savings. Classical economists believe that the economy will correct itself because the income generated by making something generates sufficient full employment equilibriums. Keynes is saying that's not true. Keynes says that there are leakages in an expense stream and injections sometimes. And so, for example, if you earn $1 by making something, but then you save some of that dollar, there won't be enough consumption to buy a dollar's worth of output. And now we're going to introduce government spending and exports, imports, which have injections and leakages of their own. So it's a little more complex. So we're going to develop one aggregate expense line. We're going to do that by developing C, IG, G, Xn, summing them to get the current equilibrium. And we're going to discover what's true at non-equilibrium points, and then develop the marginal propensity to consume and the marginal propensity to save, the slope of the consumption and savings lines, to develop the multipliers. So we're really bringing a lot of the information we reviewed in prior lessons together. We're going to practice calculating the different variables. So let's begin. We're going to include government spending in Xn. Taxes. When you introduce government, you're going to have taxes, and that means gross domestic product will no longer equal disposable income. So you'll have gross domestic product equal to national income, equal personal income, but then you have to subtract taxes to get disposable income. Business spending versus savings. At equilibrium, business spending plugs the leak of savings in the consumption stream and in the expense stream. But below equilibrium, business spending will be larger than savings. Buying will be greater than making. And above equilibrium, business spending will be less than savings, and making will be greater than buying. And at equilibrium, IG will be equal to S. This is important because when we're at a disequilibrium point, the invisible hand takes over. People's self-interest takes over and will result in a return to equilibrium. Xn, we are going to assume that exports equal imports, so there's no leakage. If imports were greater than exports, there would be a leakage, because although we get the goods, they get the income. And exports would be an injection. They get the goods, but we get the income. Taxes are a leakage from disposable income, but they can be plugged by government spending. In a private closed model, government didn't exist. What would taxes be? Zero. What would G be? Zero. And there would be neither an injection or a leakage. If Xn didn't exist, what would exports be? Zero. What would imports be? Zero. Would there be a leakage or an injection? There'd be neither. The only leakage in a private closed economy is savings. And at equilibrium, IG is equal to savings. And so if IG is equal to savings, the leakage is plugged. Let's practice by calculating some variables. This is a point on the aggregate expense line that is below equilibrium. Here's equilibrium. This point would be over here. So below equilibrium, which is larger, GDP making or aggregate expenditures buying? Two different approaches to the definition of GDP. And you can see that below equilibrium, buying is greater than making. If buying is greater than making, there'll be unplanned inventory decreases. That's good for the businessman. He's selling more than he anticipated. And as a result, he'll produce more. And unemployment will go down. Income will rise. And consumption will rise as a result. Okay. Solve for disposable income. Well, $390 total personal income minus taxes of 20 gives you disposable income of $370. Solve for consumption. Disposable income is $390. There are only two things you can do with your income: consume or save it. $360 minus 10. This is just savings. Disposable $350. 375 minus disposable, this savings of 5 is 370. 390 minus 0 is 0. Solve for consumption. Savings equals 0. What is this called? This is called break even. Okay, if we look at a consumption schedule, here's break even, where disposable income equals savings. In this example, that is 390 here and 390 here. Break even. Don't confuse that with equilibrium. Equilibrium will not happen at break even because we have to add in IG, G, index N to get total aggregate expenditures. Solve for savings. 410 minus 405 is 5. The only two things you can do with disposable income is consume it and save it. Solve for gross domestic product. That should be on this line. Well, working backwards, 450 minus 20 is 430. 450 plus 20 is 470. Okay. 490, what are taxes? 490 minus 470 gives us taxes at 20. Notice that taxes are consistent at 20. The constant amount of tax at all levels is referred to as a lump sum tax. This is a somewhat unrealistic assumption because in truth, the federal tax code is a progressive tax code. The more you make, the higher percentage of income you pay. For simplification purposes, we're going to show it as 20, constant, regardless of changes in income. Okay, now, notice here, gross domestic product equals aggregate expenditures, and that's called equilibrium. What's investment? 20. We're going to assume that investment is constant at 20, regardless of changes in GDP. You can remember that we did that here. Business spending is a constant amount regardless of changes in GDP. That's going to be 20. At equilibrium, consumption is going to be 450. This is the consumption line. What's net exports going to be? We're going to assume that is 10. Notice that trade is assumed to be balanced. We're exporting 10, we're importing 10, there's no trade deficit. So we can drop 10, we drop 0 here, and we're going to assume that imports and exports don't change with regard to GDP either. What's savings at equilibrium? Disposable income minus consumption gives you savings of 20. And what is government spending? That is also going to be a constant amount of 20 regardless of changes in GDP. So our assumption that GDP does not change either when it comes to changes in output. Here's break even. We have 0 savings. This is the 0 line. This is 0 savings. This happens at break even of 390. But at income of 450, we have savings of 20. 450 and consumption of 470. This should be 470. And that consumption of 450. If we go up to the 45-degree reference line, that's 470, right? Disposable income. And this difference of how much we're consuming at 450 and how much our total income is gives us savings of 20. And that's this 20 here. So now we can add our variables and get 450, consumption at equilibrium, 20, business spending at equilibrium, government spending at equilibrium, and net exports, 490. This is our equilibrium level of aggregate expenditures and GDP. This is aggregate expenditures actual. We don't know if that's full employment. We don't know if it's recessionary or inflationary yet. We have to have another line to tell us that. Solve for GDP, 490. Disposable income plus taxes, 510. So we've practiced calculating our different variables along the formula of CIG, GXN, now that we've introduced government spending and imports and exports. And we have taxes. Notice that the taxes is a leakage from the income stream, it's a subtraction, but government spending plugs the leak because it's an injection. There's no leakage or injection with exports and imports because we're assuming trade is balanced. Find equilibrium. Equilibrium, gross domestic product, equal to aggregate expenditures. At equilibrium, what are the potential leakages? The leakages are taxes plugged by government, savings plugged by IG, government, savings and IG, imports and exports. What is true at equilibrium concerning leakages and injections? They're equal. Below equilibrium, this is part of the aggregate expense line. Below equilibrium, which is larger, buying or making? Well, if we go, say, to 470 GDP, aggregate expenditures are 475. The purpose of the 45-degree reference line is to show us which number is larger. If you're on this side, aggregate expenditures will be larger than GDP. GDP is 470, but below equilibrium, aggregate expenditure 475. Buying is larger than making. And as a result, there will be an unplanned decrease in inventories, which businesses will react to by producing more because they want to sell as much as they can. Unemployment will fall. Income will rise. Income is the primary explainer of consumption, so consumption will rise. But it won't rise for dollar, it won't be a 45-degree reference line because some of the money will leak out into savings. So you'll continue up this way until you hit equilibrium, where buying is equal to making, and there's no reason for businesses to change how much they're producing at that point. Above equilibrium, let's try 510 GDP. Come over. Now 510 GDP, aggregate expenditures of 505. So now, GDP, think of GDP as making or income, and aggregate expenditures, think of this as buying. Right? The expense approach to GDP, the income and output measures of GDP. At 510, gross domestic product will be larger than aggregate expenditures. Making is larger than buying. That means there will be an unplanned inventory increase, which is bad for businesses. They're not selling everything they're making, and that is expensive for businesses, so they will lay workers off. Unemployment will rise. Income goes down. Consumption goes down, but it doesn't go down dollar for dollar because some of the lost income will be made up by withdrawal from savings. So they'll continue down this line until we get to equilibrium, where buying is equal to making, and there's no reason for businesses to change output. At equilibrium, GDP and aggregate expenditure equal, and buying is equal to making. Now, if we try to calculate the multiplier, we're going to need to know what the marginal propensity to consume and the marginal propensity to save is. To do that, the marginal propensity to consume equals the change in consumption divided by the change in income. So let's take, it doesn't matter because it's a line, it doesn't matter what 2 points you take. So let's take these 2 points. Income is changing by 20 here. And income is changing by 15. The marginal propensity to consume is 0.75. That means every time you get an extra dollar, marginal propensity to consume, marginal for how likely it is, propensity for how likely it is to consume marginal an extra dollar. So if you get an extra dollar, you'll consume 75 cents of it. What's the marginal propensity to save? There are 2 ways of calculating this. 1 minus the marginal propensity to consume equals 0.25. There are only 2 things you can do with a dollar. an extra dollar, consume it or save it. The other way of calculating this is the change in savings over the change in disposable income. We know that the change in disposable income, we'll use 20, and the change in savings will be 5. 20 minus 5. That's 5. So this is 0.25. Alright, so now we can calculate the multiplier. Now, when we did averages, remember, we're not using averages. We did averages at the very first lesson in this unit. An average, all the information comes from one line. It's a snapshot. A marginal is a change measure. You're comparing data from two different lines. Now we can calculate the multipliers. So, the spending multiplier is 1 over the marginal propensity to save. That's 1 over 0.25. The spending multiplier will be 4. The tax multiplier will equal a negative marginal propensity to consume divided by marginal propensity to save. That's going to equal 0.75 divided by 0.25 negative. That gives us a negative 3. The tax multiplier will always be 1 less than the spending multiplier and a negative. And there's something called a balanced budget multiplier, which will always be equal to 1. This is a lot of information. We've really brought together, in a review type of way, a lot of the information we've covered before, and we've gone into more depth about injections and leakages, which is critical to understand what Keynes is trying to do when he claims that there's a more active role for the government in managing the economy. Because income sometimes is not sufficient to generate the purchase of the output produced. And we're going to use, when the government interferes in the market, to restore us to full employment, either from a recessionary equilibrium or an inflationary equilibrium. They don't have to spend the entire difference between full employment and actual. They can spend a fraction of it, and the multiplier will magnify that change in government spending to return us to full employment.